We're just going to have a quick recap of heat energy, okay, and in particular this time specific heat capacity, okay. So specific heat capacity is defined as the amount of energy required to change the temperature of a 1 kilogram mass by 1 degree Celsius. So that means that if you are heating up 1 kilogram and you want to raise it by 1 degree Celsius, the specific heat capacity is the exact amount of energy you need to raise it by that 1 degree, okay. If you are wanting to lower it by 1 degree Celsius, the specific heat capacity is the value of energy you need to remove to let that happen, okay? And so we've got our equation here that we've talked about in class and we've talked about online. So our equation is EH equals mc delta T. EH being heat energy, m being mass, C is our specific heat capacity, and delta T is our change in temperature. And I'm just going to add the units to this for us here. Remember that mass is always measured in kilograms. Our change in temperature will be in degrees Celsius or Kelvin because they're the same value. So it's just the change, the difference between the two numbers, okay? Our specific heat capacity is joules per kilogram per degree Celsius, okay? And our heat energy is energy, so it's obviously measured in joules, okay? So what we're going to do is a quick worked example. We're going to have a look at this, excuse me, and just look at it in action, okay? So, in our worked example, how much energy is used to heat 2 kilograms of water from 20 degrees Celsius to 60 degrees Celsius, okay? And so, as I've always taught you, the first thing you do with all calculation questions is you write down what you know. So, I'm going to change the colour of pen so that you can see the difference. And what do we know? Well, we know that the mass is 2 kilograms. Okay, and then we've got temperature 1 is 20 and temperature 2 is 60. So our change in temperature there is going to be 40 degrees Celsius. Our specific heat capacity is the harder one to get, or in some cases the easier one to get, depending on how you look at it. You have to remember that you have to use this table that I've got pictured over here, okay? This table is at the start of all tests you do, all assessments, all of that. It's there, okay? And this table is our table of specific heat values, okay? And so we're doing a calculation here that involves water, so that's the one at the bottom there, okay? So we're just going to go and use this value at the bottom. Okay, so that means for our specific heat capacity, that's 4,180 joules per kilogram per degree Celsius. Okay, and so the next step that we do in all calculation questions is we write down our equation, and then that's our first mark in a 3-mark question, remember that. Our second mark comes from subbing in our values, so we'll have 2 times 4180, and then that will be multiplied by 40, and that is our second mark for putting in our values in the correct places. And our final answer in this question is 334400 joules, or 334.4 kilojoules if you want to put it in scientific notation. Okay? Latent heat. Okay, now latent heat is defined as the amount of energy required to change the state of a 1 kilogram mass. Okay, and it's given by the equation EH equals mL, where EH is heat energy, m is mass, and L is the latent heat. And again, we've got our units of mass being kilograms. The units of latent heat are joules per kilogram, and the units of energy are joules. Okay, and so what we're going to do is we're going to use these, but we have to remember with latent heat that we're dealing with objects changing state, and so we've got 2 different state change points. We've got the state change between solid and liquid, and we're going both directions there, and that is what we call the point of fusion. Okay, and then the other side we have liquid and we have gas, and that is what we call the vaporization. Okay, and so if you look at the table, if you look at the table that I've got here, you'll see that the top table is the specific heat of fusion of materials, and the bottom heat is the specific latent heat of vaporization of materials. The bottom table is for this liquid to gas side, and the top table is for this solid and liquid side. So if you're changing something from solid to liquid or liquid to solid, you're going to be dealing with the top table, and if you change something from liquid to gas or gas to liquid, you're going to be dealing with the bottom table. Okay. So, worked example time, and I'm going to use red again. So, how much energy is required to melt 3 kilograms of iron? Okay, so first things first, writing down, we know the mass is 3 kilograms, and we need to know what L would be for iron. So I'm just going to jump back a page, and you can see that for iron, so the third one up, so for iron it's 2.67 times 10 to the 5. Joules per kilogram. Writing down our equation, EH equals ml, substitute in our values, you can have 3 times 2.67 times 10 to the 5 801,000 joules, which is 801 kilojoules. Okay, and that was how you would solve a latent heat question.